So we have this example again, example 13. Amount of money is invested for 4 years at 3% per annum, interest compounded quarterly. And you used a geometric sequence concept in order to solve this problem. But your calculator does have a finance solver, so that's what we're going to have a look at. So I'll flick over to the finance solver, to your GDC here. And I've got a new calculator happening. If you want to follow on yourself, that would be great. Don't have to, but it's useful to get the sort of kinesthetic kind of learning by actually doing as I go. So under the menu button from a calculator screen, you can see number 8 there is finance. And then if I press 8, I've got a whole bunch of problems, but the one I'm only interested in is the finance solver here. So I press finance solver, and I've got all of these values that I need to fill in. Now, the finance solver will let you find an unknown one of these values if you fill in the rest of the information. So I'm just going to solve the problem that was on the screen a second ago and go from there. So it says how many payments are going to be made. In this case, if you remember, it was quarterly over 4 years, so it's 16 payments. What was the interest rate? Well, you can just leave that as 3%. That's what we were given. It was a 3% interest rate per annum. What was the present value? Now, the present value is that I'm giving $5,000 to the bank to hold onto. So the present value is actually negative 5,000. I've given over $5,000. Okay. The payment, we're going to leave blank. Now, payment, because this is a general finance solver, it could be used, say, for example, if this was a loan and then you need to make payments every period, then you could put in an amount here as well. The final value or future value, I always call it final value. The future value is what it's going to end up being. If I press return now, I'm going to get the wrong answer. I'll explain why in a second. So if I press enter, it will calculate it, but it's $8,023. Okay, and that's because of the next two, when it should be what, 5,634. And that's because I also need to set these two values as well. I need to say that it will be paid out 4 times a year, and the compounding periods are 4 times per year as well. So both of those things need to agree. So 4 and 4. And then if I go to future value and press enter, it gives me the answer, $5,634.96. Is it cents? Is it dollars and cents, or it's pounds and pennies? So £5,634.96. What do you think? Tab. Try using tab. Yeah? Yeah, cool. Yeah, I find the interface to be quite clunky. I find this thing here is like, it drives me crazy, really. So I tend to get used to using the numbers to move between the menus and then using tab and enter to go. I'm pressing the tab key right now to go between things. So even though your trackpad will do the same thing and you can use your trackpad to scroll down here, I find it quite painful on the actual graphics display calculator itself. Now, I've got more to show you, but does anyone have any questions about that? It's nice and easy, isn't it? If you make this positive $5,000 because you don't think, whoops, that's okay. It'll end up being negative $5,634 as your final value, but you would just write down without the negative sign. Okay, so it doesn't matter as long as you get your signs right in the end. But contextually, it kind of makes sense that I've given $5,000 away and I'm getting back 5,634. Now, this finance solver is really good for analysis. So, and you can potentially get asked questions. So, for example, you might be told that it's the same problem. It's it's over 4 years compounding quarterly, so N is 16. And let's just say you're told that the amount of money that you get back is £6,000 exactly. Or it might be that told, who was the name? Oh, it doesn't say who it is. That the person wants to get £6,000 back after 4 years. What interest rate should that person be shopping around for? So you can put in the final value of 6,000, keep the payments per year and compounding periods per year the same, and then go to the interest rate and press return there. And you can see that it's now an interest rate of 4.58 will get you roughly £6,000, or you'd need to get an interest rate of 4.59 if you want to make sure you're clearing £6,000. Does that make sense? And then you might go, okay, well, let's make it 4.58. How close would I get? Go back to the final value, press return. I'd actually be £1 short. Is that good enough? You could argue it is. You could argue that it isn't. 4.59, £6,001 now and 40p. So there you go. So you can work out different values at all as well, or you can say instead, let's just say we put the original amount in, which was £5,634.96p, and let's just say the interest rate is doubled to 6%. How long will it take to reach the same final value? So you put in the values that you've got, go up to N and press enter. There you go. It'll take not 8 compounding periods, but 8.03, which means that you'd probably have to go to 9 compounding periods in order to get that final value that you're looking for. So it's not exactly half. It's a little bit more than that. Okay, so basically you should be able to solve most problems by simply using this finance solver if it's a calculator-based question. Any questions on that? And they tend to be, because you're dealing with decimals, which is difficult to do in a non-calc section, but not impossible. I just wanted to show you, like, here's an example of an IB question. This is from an exam or something. On 1st of January 2020, Laurie invests P dollars in an account that pays a nominal annual interest rate of 5.5% compounded quarterly. The amount of money in Laurie's account at the end of each year follows a geometric sequence with common ratio R. Find the value of R, giving your answer to 4 significant figures. So you can see here's the calculation here to work out that it would be 1.056 for R. That's just 5.5 divided by 4, turned into a decimal, add 1 to it. That's 1.056. That's nothing to do with it. B, Laurie makes no further deposits to or withdrawals from the account. Find the year in which the amount of money in Laurie's account will become double the amount she invested. Okay, so I just want to point out that you can see that in the mark scheme, this is official IB mark scheme, it's given a geometric sequence approach and it's given a finance calculator approach. And you can see that they're expecting you to write down those things that I showed you on the screen, in the order that you've got, if you like, PV, FV, I, payments per year, compounding interest per year, and then you get a value out of it. The only thing I'm not too sure about, and I haven't had a chance to go through it, I'm not too sure why it says final value plus or minus 1. Here it says plus or minus 2, which makes more sense to me. So I'll explain the difference between these two in a second, but yeah, that I'm not too sure why that's plus or minus 2. That's plus or minus, minus or plus 1. I think it should be 2 as well. but I'd have to look at it properly in case I'm wrong in there. And yeah, but why 1? Well, because effectively we're just putting in any value for the principal value, and then we're putting a doubling at the end of it. So why not use 1? That's why 1's in there. You can't just put P and then 2P in for the final value. Also, you can sort of see that if I look at this line here, I could divide out the P here to get 2 is equal to 1 times this. So 2 and 1. Just the difference between these two here is that if you use the reduced interest rate, i.e. if you use the interest rate of the per quarterly interest rate, then payments per year is actually going to be payments per time period, and compounding rate per year is actually going to be compounding rate per time period. So if you use the interest rate that you got from dividing the per annual interest rate by 4, that's why you would do it that way. But as you can see, it's a bit more straightforward if you just ignore all that and then just go, well, I know what the interest rate is per annum, it's 5.5, put that in, and then just make sure my P/Y and my C/Y agree with each other. So there you go. So you'd put that in, and then you'd get your solution from there. So again, just I'll quickly go through that very briefly. We're going to menu, we're going to finance, we're going to finance solver. We're putting in the amount, the things that we know. And we are pressing enter on the thing that we don't know, including the periods. And then we're putting in the so we go to the thing that we don't know and press enter, and it will calculate it based upon the rest of the information. And that's basically how you use it. Now, you could use that financial solver for where you are right now, or possibly slightly better, you can go to 5E.5, and there's a bunch of questions there in 5E.5 on page 122, and those are, I haven't done them myself, but they look like they've been designed to use your financial solver for. So again, in terms of an IB test or a test that I create, if you use a geometric sequence, that's fine. But if you're going to use your finance solver, part of what you'll get marked for is writing this stuff down. N. Obviously, there'll be something you don't know, but whatever you do know, you write down N, I, PV, FV, P/Y, and C/Y. You write all of those down as part of your working out, and then your finance solver will give you the number that you're looking for. Any questions? Okay, get stuck into it. Exercise 5E.5. See how far you can get in the next 10 minutes.